Hello, my name is Ann Edwards. I will be talking about the research and development company Xerox PARC. Our agenda will be the history of the company, today's culture, and the company's contributions. We will first dive into the founding of PARC. PARC was formed in 1970 by Jacob E. Jack Goldman, Xerox Corporation's chief scientist. Xerox Corporation assembled a team of world-class experts in information and physical sciences to become what is known as the architects of information. In July of 1970, the company establishes the Xerox Palo Alto Research Center under the direction of Dr. George Paik. The charter for Xerox PARC is to create the Office of the Future. The culture of PARC. In 2002, Xerox PARC transformed into an independent, wholly owned subsidiary company dedicated to developing and maturing advances in science and business concepts with the support of commercial partners and clients. Using an open, innovative approach, PARC offers custom R&D services, technology, user experience expertise, and intellectual property to Fortune 500 and Global 1000 companies, startups, and government agencies. Work is centered around a series of focus areas that is believed to be the future of technology. These focus areas are artificial intelligence, AI, and human-machine collaboration, digital workplace, novel printing, Internet of Things and machine intelligence, digital design and manufacturing, microsystems, and smart devices. Work in artificial intelligence and human-machine collaboration is at the forefront of a new transformative era of machine intelligence. It is characterized by trust and understanding, creating a path for autonomous and self-learning systems to play an ever more important and collaborative role in our everyday lives. The way people work is changing right before us. Gone are the days of being tied to an office and a desk. In the digital workplace, creative technologies allow individuals, businesses, and governments to rethink how people work, collaborate, and interact with virtual assistants and physical workspaces. Novel printing includes rapidly growing areas of on-demand printing, industrial printing, flexible electronics, and additive manufacturing. Thanks to easier connectivity and better analytics, businesses are now moving their physical systems towards an IoT-empowered digital world. With analytics, Xerox labs are creating smart sensors and systems that enable rapid, reliable, and secure data collection at scale. This data can then be used to develop actionable insights, or as the backbone of systems that will be the forefront of a rapidly changing technology landscape. Through innovations in artificial intelligence, integrated planning and control, and additive manufacturing, organizations can create a greater variety of products and dramatically reduce the time required to design complex engineered systems. Xerox interdisciplinary work unifies principles of computational physics, geometric reasoning, automated spatial planning, and field modeling to help engineers create entirely new kinds of products. PARC scientists take important hardware systems like sensors, actuators, displays, and cameras and reinvents them to be accessible and versatile for use in a number of different advanced technologies that make a difference to our lives. Every piece of hardware is designed with size, form, factor, affordability, manufacturability, and usability in mind, often combined with smart analytics. Accomplishments and contributions to the tech. In 1971, Xerox PARC modulates a laser to create a bitmapped electronic image on a xerographic copier drum. Not only does this demonstrate a novel way to print documents, but this invention of laser printing enables seamless rendering of digital documents onto paper. 1972, Xerox PARC designed Smalltalk, an object-oriented programming language that enables programs to be improved without being entirely rewritten. This innovation revolutionizes the software industry and influences subsequent programming systems. 1973, the Palo Alto PC is created. Its client-server architecture means computing is no longer restricted to the hierarchical world of large centralized mainframes. This evolving PC will subsequently employ the world's first bitmap display, graphical user interface with windows and icons, WYSIWYG editor, local area network and file storage, and commercial mice. An internal memo proposes a system of linking workstations, files, and printers together using a coaxial cable within a local area network. The benefit is that the components can join or leave the network without disturbing data traffic. The memo's author coins the term Ethernet to describe the network. 1974, Xerox PARC coins the phrase to describe cut and paste bitmapped editing. What you see is what you get, also known as WYSIWYG. 1975, PARC debuts the first GUI, which uses icons, pop-up menus, and overlapping windows that can be controlled easily using a point-and-click technique. 1979, to enable spell checking, dictionary, and other tools, Xerox PARC invents computational linguistic technologies based on understanding the structure of language. 1987, PARC designs a 16-bit coding system to represent any world script in documents, usernames, file names, or network services in any combination with a single encoding. 1989, PARC invents techniques that use human perceptual and cognitive capacities to help people make sense of large amounts of diverse information. And in 1990, PARC creates Lambda Mu, one of the oldest continuously operating real-time multi-user dungeons or online environments. Thank you for listening, and I hope you learned a little bit more about Xerox PARC.